Practice problem 10.13, okay, is a partial pressure problem where you have a mixture of 6 grams of oxygen gas and 9 grams of methane gas is placed in a 15-liter vessel at 0 degrees Celsius. So we're looking for the partial pressure of each gas and then what is the total pressure in the vessel. Okay, so the first thing we need to recognize is that we're starting with the moles of O2, okay, which we have 6 grams of O2 times in 1 mole of O2, there's going to be 32 grams of O2. Okay, so our grams are going to cancel, and so we can figure out how many moles of oxygen gas we're starting with, which is 0.188 moles of O2. Well, we also are starting with our moles of CH4, so we have 9.00 grams of CH4 times in 1 mole CH4, we have a total of 16 grams of CH4, methane. Okay, grams cancel, and so what we're left with is 0.563 moles of O2. So now we want to know the partial pressure. Well, we first need to find the pressure of each individual one. So let's start with, we're looking for the pressure of O2, okay, which is just going to be equal to the moles of O2 times R times T divided by V. And so what we have here is we have 0.188 moles of O2 times R, 0.0821 moles, or liter atmosphere per mole Kelvin, times the temperature, which is going to be at 0 degrees Celsius, so we just know that's 273 Kelvin, divided by the volume, which is going to be 15.0 liters. And so what we find is that we have 0.281 atmospheres. All right. We can then do the same thing for the partial pressure of the methane. Okay, so here we have 0.563 moles of CH4 times 0.82 or 0821 liter atmospheres per mole Kelvin times the 273, which is going to be the same here, and then we can divide that by the 15.0 liters, and so what we find is we get 0.841 atmospheres. Okay, so then the final question is, that is the partial pressure of each gas. Well, what is the total pressure? Well, it's just those two added together. And so we get a total of 1.122 atmospheres for the total pressure of that gas. So we're given gram. Once we find the moles of that, we can then convert